Hi kids, hope you are all doing well. Today I'm going to continue with the chapter on fractions. We're going to learn types of fractions today. Okay, so let us begin. I'm going to show you some few slides so that you all can understand the kinds of fractions well. Now first we have the like and unlike fractions. Now can you all see in the slide? Like fractions are a set of fractions which are having the same denominators. You have three squares over there. Each square is divided into four equal parts. In the first square, one out of the four parts are shaded. In the second square, two out of the four parts are shaded. And in the third square, three out of the four parts are shaded. All the three fractions, 1 upon 4, 2 upon 4 and 3 upon 4 are having the same denominators. Such fractions are called like fractions. Then we have unlike fractions. Now look carefully at the circles below. There are three circles. The first circle is divided into two parts. The second circle is divided into three parts. And the third circle is divided into four parts. The first circle is expressed as a fraction 1 upon 2, since only one part is shaded. The second fraction is expressed as 2 upon 3 and the third one as 3 upon 4. Now all the three fractions have got different denominators. Thus they are called unlike fractions. So how do we separate like and unlike fractions? Like fractions are a group of fractions having the same denominators. Unlike fractions are a group of fractions having different denominators. Now, the next kind of fraction that I have is the unit fraction. Now, what is a unit fraction? A unit fraction is a fraction having numerator 1. You all can see in the slide, there are circles shown here. In each circle, only one part is shaded, and thus 1 is a numerator everywhere. Now such fractions where 1 is the numerator, the denominator may be anything, but the numerator has to be 1. Such fractions are called unit fractions. The next kind of fractions are proper fractions, improper fractions and mixed numbers. What are proper fractions? Proper fraction is any fraction in which the numerator is smaller than the denominator. The numerator will be a smaller digit and the denominator will be a bigger digit. Improper fraction is any fraction in which the numerator is big and the denominator is small. You can look in the figure there. The fraction is 7 upon 3. So the numerator is a bigger digit and the denominator is a smaller digit. Such fractions are called improper fractions. And then finally we have mixed number. What is a mixed number? A mixed number is a combination of a whole number and a proper fraction. In the figure we can see, in the mixed number we have the whole number as 2 and the proper fraction is 1 upon 3. Together we get the mixed number 2 1/3. Okay children, I hope you all got an idea of what are the different kinds of fractions looking at the slides. Now I just want to make some things clear over here. First is the concept of improper fractions. Like when I was in school, I used to always wonder, what are these improper fractions? What do you mean by 7 out of 3? How can we have 7 parts out of 3 parts? So just to get that concept clear, I am going to explain to you all the improper fractions a little in detail. Now in the slide we saw that there were 3 strips of paper. Or we can say any 3 strips were given. There were 3 equal strips. Each strip was divided into 3 equal parts. Okay, my figure may not look very accurate, but imagine that there are 3 equal strips. Each strip is divided into 3 equal parts. Now the first strip, all the 3 parts were shaded. So if I shade all the three parts, how will I express it as a fraction? I will say 3 out of 3. 3 out of 3 parts are shaded. In the second strip also, all the 3 parts were shaded. So as a fraction, it will be expressed as 3 out of 3. In the third figure, only one part was shaded. So how will I express the third figure? I will say 1 out of 3. Okay, so these are my 3 strips. In the first one, 3 out of 3 parts are shaded. In the second one, also 3 out of 3 parts are shaded. And in the third one, 1 out of the 3 parts are shaded. Supposing I want to tell altogether how much is shaded, how will I express it? So I will add up all the shaded parts. First one 3 out of 3, second one 3 out of 3, and the third one 1 out of 3. So altogether this much is shaded. Now look here children, all these fractions have the denominator 3. So they are like fractions. Remember I just showed you all what are like fractions. Group of fractions having the same denominator. So these are also group of fractions having the same denominator 3. Now when you want to add like fractions, the method that you have to follow is you just add their numerators. So the numerator 3, second numerator 3 and the third numerator 1. And the denominator remains the same. It was a 3 here, it was a 3 here, it was a 3 here. So the final answer will also have 3 in the denominator. So this is how you add like fractions. Only the numerators are added upon the same denominator. Denominator does not get added, it just remains as it is. So what is 3 plus 3 plus 1? It is 7 upon 3. So when I was talking about an improper fraction 7 upon 3, this is what I meant. This is what is 7 upon 3. 3 upon 3, 3 upon 3 plus 1 upon 3. So this is a clear idea of what are improper fractions. Now let us see how improper fractions and mixed numbers are interrelated. Now look here in the first figure, the entire strip is shaded. 3 out of the 3 parts are shaded. So I can also say that the whole strip is shaded. One full strip is shaded. Similarly here also, one full strip is shaded. In the third case, only 1/3 is shaded. So if I want to express it, I can also express it in another way. I'll put an or here. The other way of expressing would be one full strip plus one more full strip plus 1/3 of the third strip. So one whole plus one more whole will make 2. So I have 2 full strips shaded plus 1/3. So it becomes 2 and a 1/3. So if I want to say how much of the strips are shaded, I can either say 7 upon 3 is shaded or I can say 2 and a 1/3 is shaded. Now this is an improper fraction. This is a mixed number. But the value is same. 2 and a 1/3 and 7 upon 3 are equal. So I can also say therefore 7 upon 3 is equal to 2 and a 1/3. Okay. So this is how mixed numbers and improper fractions are related. I hope this concept is clear to you all. What is the meaning of an improper fraction? Okay children, now let us go to exercise 4C from your maths textbook. The first question says, point out the proper and improper fractions from the following. You all are given 10 fractions. You all don't have to do anything much here. Just identify whether it is proper or it is improper. Write down the fraction in your notebook. Put an arrow over there and just mention proper fraction if it is proper. If it is improper, write the improper fraction. Now let's go to question number 2 from exercise 4C. Okay, question number 2 says, convert the mixed fractions into an improper fraction. So you are given mixed fractions and you are asked to convert them into an improper fraction. I will solve a few examples. My first example is 5, 3 upon 8. So this is a mixed fraction. The whole number part is 5. The fraction part is 3 upon 8. Now this fraction has to be converted into an improper fraction which will have the same value as this fraction. So what is the method? This is the numerator, this is the denominator, this is the whole number. So you have to follow a circle in the backward fashion. So 8 will be first multiplied by 5. So I can say denominator will be multiplied by the whole number, denominator by the whole number, and then it will be added to the numerator. Okay, it's like a circle going backwards. Denominator into whole number plus the numerator upon denominator. Okay, so what is the value of the denominator? 8. The value of the whole number is 5. So multiply by 5 plus the numerator. So plus 3 upon denominator. Denominator does not change. It remains the same. So it will be 8 only. Now let us work out this part. What is 8 multiplied by 5? 40 plus 3. So it is 43 upon 8. Okay. So 5 3 upon 8, which was the mixed number, has now been converted to an improper fraction, 43 upon 8. Let us take another example. Six 7 upon 9. Now children, when you solve these sums in the notebook, please follow the same steps as I am doing. Your first step, I want you all to write the formula. That is denominator multiplied by whole number plus the numerator upon denominator. Also get into a habit of drawing these arrows so that you all don't forget the method. Multiply and then plus. Okay, so this will be your first step. Your next step will be putting the values. Denominator has a value of 9, whole number has a value of 6, numerator has a value of 7 upon denominator, that is 9. What is 9 multiplied by 6? 54 plus 7, 61. So the answer is 61 upon 9. Okay, I hope this is clear to you all. So we have converted mixed fractions into improper fractions. Okay, now let's go to question number 3. In question number 3, you have to do just the opposite. You are given improper fractions and you have to convert them to mixed numbers. Let us take a few examples. 23 upon 7. This is an improper fraction. It is having a big numerator and a small denominator. Now here in the rough column, I want you all to do the division. 23 is the numerator. The numerator word has the alphabet N in it. So remember, numerator has to always be inside when you are dividing. N for numerator, N in inside also. So numerator inside, that is 23 inside, denominator outside. Okay, so 23 divided by 7. We have 7 3s are closest to 23, that is 7 3s are 21. Remainder is 2. Okay, my division is done. I have got a quotient, I have got a remainder. Now the quotient will be your whole number and your remainder will be your numerator. So when I want to write this as a mixed number, it will be written as, the quotient is the whole number, so 3 will come here. 2 is the numerator, so 2 will come here. The denominator does not change, it remains as it is. So if it was 7 here, it will be 7 here also. So the improper fraction is converted to a mixed number. It is 3, 2 upon 7. Let us take another example. 49 upon 8. So what do we do? Numerator inside, denominator out and divide. We have 8 6 48. This will give me a remainder 1. So I will have 6 as the whole number, 1 as the numerator. Now let me write my mixed number. What will be the whole number in the mixed number part? I have to ask questions and I only have to answer it. We don't have a choice. So 6 is the whole number. 1 is the numerator and the denominator was 8 here, and the denominator will be 8 here as well. So the mixed number is 6, 1 upon 8. Okay, so I hope this is clear to you all. So we are done till question number 3. Now let's go to question 4. Okay children, now we move to question number 4. Now in question number 4, you are told convert the unlike fractions into like fractions. You are given a group of fractions here. You can see the denominators are all different. So they are unlike fractions. Now you have to make this unlike fractions into a group of like fractions. Now how do we go about this? The first step is to find the LCM of their denominators. I hope you all remember what is LCM. It is the lowest common multiple. And how do we find it? We have to work it out in the rough column. I'm going to write all the denominators together here. 4, 6, 8, 9, 12. Now we have to go on factorizing this using only prime numbers. Remember your prime numbers 2, 3, 5, 7, 11, 13, etc. So we have to factorize this only using prime numbers. I will always prefer to begin with the smallest prime number, that is prime number 2. I have told you all any even number, that is a number ending with 0, 2, 4, 6, 8 can be divided by 2. So I will make use of the first and smallest prime number, that is 2. Now let's see which all numbers can be divided by 2. 4 can be divided by 2, 2 2s are 4, 6 can be divided, 2 3s are 6, 8 can be divided, 2 4s are 8. 9 cannot be divided by 2, it's an odd number. Now the number which cannot be divided, just get it down as it is. So I'll bring the 9 down. 12 can be divided, 2 6s are 12. So first step is done. Let me go to the next step. I still feel I can use the prime number 2 because there are many more numbers which will be divided by 2. So 2, 1s are 2, 3 will not be divided, get it down as it is. 2 2s are 4, get down the 9, 2 3s are 6. Once more I will use 2 because there is a 2 here. 1 comes down as it is, 3 will come down, 2 will now become 1, 9 will come down, 3 will come down. Now if you look here, there are no numbers which can be divided by 2. So I will go to the next prime number, that is prime number 3. Get the 1 down, 3 will now become 1, this 1 will come down, 9 will become 3, 3 3s are 9, this 3 will become 1. And now again I will make use of 3 to get rid of this last 3. 1 comes down, 1 comes down, this 1 will come down, 3 will become 1 and 1. So you can see all the numbers have been factorized and everything has been made to 1. Now how do we find the LCM? To find the LCM, I need to multiply all these numbers. That is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. Okay, let us multiply and see what is the answer. So first I will do 2 multiplied by 2, that is 4, multiplied by the next 2, 4 2s are 8, 8 3s are 24, 24 3s are, let's work it out and find out what is 24 3s are. It is 72. So the LCM is 72. So I have worked out the LCM. Now what is my next step? My next step is to make all these fractions which are having different denominators into like fractions. For that I will write all these fractions down. Now their denominators are different. Now I will try to get a denominator which is common to all, and that common denominator will be my LCM. So 4 has to now be made into 72. This 4 has to be converted to 72. Now I need to multiply 4 by a certain number which can give me 72. If you know it on your own, it's well and good. Otherwise you can work out and find out 4 multiplied by what will give me 72. For that I will divide 72 by 4. 4 1s are 4. 3, get the 2 down. 4 8s are 32. So if I work out, I get to know that 4 multiplied by 18 will give me 72. So if I am multiplying 18 in the denominator, I will also multiply 18 in the numerator. So work out 18 multiplied by 3, you will get the answer. 18 threes is 54. So I will write it here. Now similarly, I need to make this 6 also into 72. 6 multiplied by what will give me 72? 6 12s are. So same thing in the numerator. So numerator will now be 5 into 12, that is 60. Here children, I know the table, so I am doing it directly. But if you all are having any problem with the table, divide and find the number. Now again 8 has to be converted to 72. 8 multiplied by what will give me 72? I think this you all should know. So it is 8 9s are. 8 9s are 72. Multiply 9 in the numerator as well. So I will get 9 in the numerator. 1 into 9 is 9. Then I have 9 here. 9 has to be made into 72. For that I will do 9 8s are 72. Same thing in the numerator. 4 multiplied by 8. 4 8s are is 32. Finally we have 12 here. 12 also has to be made into 72. 12 watts are 72. 12 6 are. Same thing in the numerator. 7 6. 7 into 6 will give me 42. Okay, so you can see here all the unlike fractions are now converted into like fractions. They all have the same denominator 72. So let me list down all these like fractions. My first fraction is become 54 upon 72. Second one is become 60 upon 72. Third one is become 9 upon 72. Fourth one is become 32 upon 72. And the fifth one is become 42 upon 72. So this is how I converted the unlike fractions into like fractions. Once again I am telling you children, first step, take all the denominators, find the LCM. The LCM that you get will be your new denominator. Multiply the numerator and denominator by the same number to get your new like fractions set. Okay, hope this is clear. So in exercise 4C, you all are going to do question 1, question 2, question 3 and question 4. Thank you. Have a nice day.